will go,
Big triangles.
it will go quickly in how I can teach it to you. They go very slow to make. There's not really something to solve for the most part either. You make them. So it's all about slope fields. Oh, look at you guys. Half of you don't even have your packets out. You're still on your phones. Because the ACT day this week is kind of very fragmented, and we basically have to do one section a day, which normally would be kind of like difficult, but this is the chapter that we can do that. So. I mean, that's one option, right? There's lots of options we could do, yeah. So I'm going to assume that most of you have never seen slope fields before. Yeah, they were in your packet. I think they're on the cover of your Unit 7 packet too. So I guess you've seen them there. A slope field is all of the solutions to a differential equation. So that's what a slope field shows you. Let me do this first. So if we had a differential equation, that's not a pen. So there's our differential equation. We've talked a little bit about how to solve them, right? So you can integrate both sides. This one, technically, we'd have to multiply by dx. And when you integrate, I picked 2x because that's going to be probably the most straightforward one we know of. So we get x squared plus c, right? If we were to draw, bless you. You got some kind of noises every day, huh? We should start rotating these. If we were to draw x squared plus c, like super quick, I'm not going to do a very good one. This would be x squared plus 0. This would be x squared plus 1, plus 2, minus 1, minus 2. It would be a lot of parabolas above and below each other. The plus c represents any number. So this would be a drawing of all the particular solutions. So a particular solution is when you know the number for c. A slope field is a drawing of all the general solutions. So what works out really weird, I mean, like, it's not actually weird, it just seems strange. The 2x, who should we go with? We got to call on somebody who hasn't been called on forever. Josh, who's sitting on his phone still. What does the 2x represent? Like, it's a derivative. So do you remember what derivatives represent?
Yeah. So 2x is going to be the rate of...
Yeah. Oh, no, you're saying the correct wording. What's the easy? Rate of change is the correct wording. There's nothing wrong with that.
Okay, I don't really know in a different way.
Slope.
Okay.
So 2x represents the slopes of all the locations on x squared. So if we draw all of the slopes, so like if I go at the point 0, 0, and I plug in 0, 0, I get an answer of 0. If I go to the point 1, 0, well, there is no y value here, so it doesn't affect it. But the point 1, 0 would give us an answer of 2. 2 times 1. the point 20 would give us an answer of 4. And so if I go very meticulously and annoyingly find every single point on this graph, if I go to the point 1, 1, that would give me an answer of 2. The point 0, 1 would give me an answer of 0. Do you know what I'm saying when I say an answer of 0? Do you want me to write out where the answer is coming from? I'm taking the equation 2x and I'm plugging in x and y values. So like the point 1, 1, x is 1, y is 1. But our equation doesn't have a y in it, so we would only plug in the x value. And if I plugged in 1, I'd get 2 times 1 is 2. If I take the point 3, 4, the x is 3, the y is 4. I would only plug in the x because this equation only has x's. Some of the differential equations we had x's and y's. This one just has x's. So this answer would be 6. And these, they take a long time. They're annoying. And rather than me drawing the whole thing, I already had it pre-drawn. I'll just pretend like I'm... So this would be what it would look like if you draw all of the points. Now, I tried to pick this one because I think you guys are pretty familiar with x squared and 2x. And I don't think I can draw on here. I should have taken a snapshot. Oh, shoot. Did I just stop the recording? I hope not. Can I? All right, it worked. Let's say we found out c was 3. Then that would give us x squared plus 3. So then what I would do is I would mark that point on there, and then I would follow the slope lines. So if I follow this line to the right, I'm going to immediately hit a line that goes up. And then if I keep following this, I'm going to get to another slope line that's a little bit steeper. And I'm just kind of like sort of connecting the dots, but using my brain to figure out in between stuff. And so if I follow those slope lines, it creates y equals x squared plus 3. So a slope field is just a picture of all of the general solutions to a differential equation you have. And I picked this one because it's the simplest. Absolutely, some of these slope fields are crazy insane. Let's make it 2x over y. And then it immediately changes. And this one would be hyperbolas. I don't know if you remember what hyperbola is. It's like a parabola, but doubled. A bottom and a top. This one would give you different hyperbolas with the c value basically affecting how wide it is, it kind of looks like. So slope fields just show you all the possible solutions. That's really all I'm trying to get across. On the AP test, there's really only 2 things they're going to ask you to do. Maybe 3. 1, draw a slope field. I've only seen that happen once. It was a free response question. That would be the only way to get it. And they only had you fill in like 9 or 12 squares. So it didn't take long. But if you get that question, that's pretty much golden for you because it's super easy. But it's been on there. The more likely way you're going to get it is they're going to give you a multiple choice question with a differential equation and say which slope field matches this differential equation. And then that's also going to be easy. We'll go over that in a minute, but you only have to plug in like 2 spots. You're generally not going to have to draw something that takes 10 minutes. We are for our notes because, well, they're low tech. We're actually like drawing them. Okay, let's go. Page 2 is right here. No. Here we go. That's the one I wanted to get to. Oh, I can't do that though. There it is. Okay, so we're doing dy dx equals negative x over y. I guess we can fill in the tables. It's not that huge a deal. This isn't going to take long because this is basically all there is to it. So even though it's kind of tedious and whatever, this is all there is. Let's see, Josh, you never got to call on anybody yet. 17. Alex, do you think you could help me fill out this first square? What am I going to do with the point 1, 1?
Put it into the equation.
Correct.
So it's negative 1 over 1, so negative 1.
Perfect. So dy dx is negative x over y, so negative the x value over the y value. Oh my gosh. Over the y value. That's going to be the slope that we draw at the point 1, 1.
And then the second one's 1.
Yeah, the opposite of negative 1.
And then it would be negative 1. And 1.
Perfect. So the rest of these only have x values. The y value is 0. Alex, who's going to help me with that one, even though they have a much easier problem than you do?
We'll go with Zach.
Which one?
B.
You want me to fill in the words or do this?
Oh, I don't care about the words.
Okay.
What happens when you plug in 1, 0?
You get like an undefined answer.
Perfect. And in fact, all 4 of these are because they all have 0 as y. Zach, last question with that. If I had to draw an undefined slope, what would that look like?
Just like
Straight
straight up.
up. So divided by 0 would look like a vertical line. There's going to be a difference between undefined or an indeterminate. If we have 0 over 0, you're not going to draw anything. If you have over 0, it's vertical. It basically would be a dotted line, absolutely. This is definitely going to be a lot easier for you because I have to scroll, but who are we picking?
25.
27, 26, 25.
That's me.
How do I do it?
Which one? Next one?
Yeah, so I'll rewrite the equation if that helps. Just because you can't see it on the screen.
One. Negative 1.
Didn't we already plug in 1, 1?
Yeah.
Yeah, we did. Why would they pick the same spot? Whatever. Okay, so sorry, what did you say it was?
Just
Negative
negative 1.
1,
Negative 1.
-1.
Negative 1. Negative 1. Negative 1. Yeah. They're all negative.
If the two numbers are the same, they would always basically cancel each other out to leave a 1 and then the negative symbol.
I
Yeah.
forgot there was a negative
Yep. Okay, so it says use the grid at right to sketch the slope field for what we calculated. Okay. So 1, 1 was 1. So I'm going to put a tiny line with a slope of 1. -1, -1 was also 1. 2, 2 was 1. -2, -2 was 1. I believe it was -1 at that point, -1 at that point. Oh, that's a bad -1, actually. Did I draw them backwards? That it was fantastic. -1, -1, +1, +1. And then which ones were 1, 0, 2, 0? So on the x-axis were undefined. Now you 100% can use patterns to help you fill these out. You don't necessarily have to calculate all of them. So I can automatically assume those are the same numbers, so they would also have a slope of -1. These would have a slope of +1. These would all be undefined. And then if I had any points on the y-axis, they would all have answers of 0. Except for the point 0, 0, which would get drawn as a dot, because that would be an indeterminate. And then if I were smart, I could calculate that the slopes would be the in-between slopes. Oh, that was a bad one. I mean, we can see that these are creating a circle. So what this is telling us, the general solutions to this differential equation would all be circles. If I integrate this, I would get some sort of x squared plus y squared equals a number. I feel like we're smart enough to integrate this now, right? Yes, no? Okay. Let me go to a new page to integrate -x over y. I know, there's not much room to write on yours. This is partially going into 7.3. 7.3 is going to be called separation of variables. Sounds terrible, horrible. We've already talked about the fact that we have to multiply by dx, so that would become over here, correct?
Yeah.
So this would say dy equals -x over y dx. Now the y can't be with the info on the right because we're going to be integrating with x's. So how would I get rid of the y? Multiply by y. And then this would say y dy equals -x dx. This is going to be called separation of variables because we moved the variables around and we separated them. This is pretty much exactly what 7.3 is. That's why I said this unit was a perfect one for not having a lot of time left and things. They're all individually easy topics. If I integrate this, I would get 1/2 y squared -1/2 x squared plus c. And if I wanted to rewrite this, I would add 1/2 x squared to the left. I would get 1/2 x squared plus 1/2 y squared equals c. And if I doubled everything, double c is still just c. So this would be a circle with different radius size. And that's the picture we just drew. Yeah, go ahead. Plus C only has to go in one spot. So you could do plus C on the left and plus C on the right, but then when you actually put them together, it would just become C. Rather than having separate C values, you put them together as one.
So the dy just disappears like dx.
Yeah?
But then when you do it alone, it becomes just y, right? If you integrate dy, it becomes y, right?
Yeah, because you're integrating one.
Oh.
Yeah, so the integral of 1 would be 1y. Okay, so I wanted to mainly show you how you get a circle even though we could see it. This might be easier. I don't remember who went. Zoe, you went. Get off your phone.
Checking my work schedule, to find out I work today. I kind of forgot that.
Who's going to help me go?
I don't know.
You can just do number. I mean, like, you don't have to.
Trying to think of one that doesn't get called on often, 'cause I feel like it's the same numbers over and over again. I feel like 19.
I was going to say, what's your lucky number? You could do that too.
You should go with 29.
I picked 19 already. That's the answer. So I'm picking.
Yeah, why 29?
31, sorry.
Because that's you and you want to
No, not me.
What did you pick though?
19?
19? Oh, I don't know. James is asleep. This might take a while to answer. James, it happened again. That's okay. I'm not mad. Honestly, if I would have noticed earlier, I would have woken you up. So you. We'll go with another number.
Oh, okay. 21.
I thought you were going to go with 29. 21, 19, 20, 21. I was hoping you could go up there and draw the particular solution through the point 0, 2.
Okay, I guess you picked me up.
You have to think how to draw? I can help guide you if you're not sure what you're supposed to draw. Yeah. This isn't like meant to embarrass people if they don't know how to do it. Okay, so what we would definitely start with is put 0, 2 on there, like draw 0, 2, like make the point. Yep, okay. So now if you follow those slope lines from 0, 2, where would it go?
Like, in like the circle pattern?
Yeah. I mean, it is a weird game of connecting the dots, and some people have a hard time visualizing it. I understand that. You just draw a circle. Circle radius 2.
Okay.
Yeah. Oh, that was actually a pretty good circle. It's a lot harder to draw a circle than it seems like it should be. That's it.
Okay.
This is the other type of question that would be on free response. I believe I remember seeing this one about 5 years ago. Is they had a slope field drawn for you and they asked you to draw the particular solution. And then that's all that's involved is you follow the slope lines. Okay, and then I want to go to the last page of your notes. What the heck? We are not going to do this matching problem together, but I want to explain to you how to go through it. So let's focus on number 1. Let's pretend number 1 is the question on the AP test, and it says which slope field belongs to that differential equation. Now, the good thing for us, bad thing being that there's 8 of them, the good thing for us is that they all have different lines, correct? So the most logical and intelligent way to go about this is pick a single spot and see which ones of those graphs would match up with your answer. And then eliminate as you go through. Most people start off by picking what would be the easiest point to pick? 0, 0. You don't have to. You could certainly pick 1, 1. Pick easy numbers. So let's start with 0, 0. If I plug 0, 0 into square root of x plus 2, I would get square root of 2, which is what, like 1.4? Ish. Yeah, I like the ish. The ish covers a lot of ground. If it's 1.2, well, then you're still close enough that the ish worked. It's 1.4-ish. All right, so I'm going to look at 0, 0 with my ridiculously bad eyes and try to find which ones have a slope of 1.4-ish. It is definitely not A. A looks like a slope of 0. B looks like it has absolutely nothing, unless it's a horizontal line, which it might be, but either way, that would be a slope of 0. We get to C. That's a maybe. Okay, D. Yeah, that's a maybe. I mean, it looks like about 1. E is a definite no. There's nothing there. F, wow, that is a crazy looking one. I wonder if that's like I wonder if this is a trig one.
Yeah, that's one of the, I think that's,
I'm assuming it's trig because it kind of goes in waves.
I think it's the,
But it is slopey of 1. G is not 1. It looks like it probably is flat. H at 0, 0 is 1-ish. Okay, so we eliminated half of them. Then we'd go through and pick the next easy spot. Did any of you know immediately why it should be D, though? You can't plug a negative number. You can't put a number smaller than -2 in there. You just get nothing as an answer. And so if you look at the graph at D, well, there is no answers to the left of -2. Now, it doesn't actually even have them marked like 1, 2, 3 or anything, but I'm assuming this is -2. Worst case scenario, you don't see that. You just pick another spot. Traditionally, you try to pick a number that's very different than what you just plugged in. Let's see. I'm looking at the equations that are there. C and D actually look sort of the same, except for on the left-hand side. F and H both sort of resemble each other. They're both wavy. So I guess I'll pick a number to the right, like 2, 0. So the point 2, 0 would give me square root of 4, which is 2, not even 2-ish. It's 2. This one is not it, because this one is also a slope of 1. Because if you look at this one, it has all the same slopes on the x-axis. So that one's out. This one we already know is the correct answer, so yeah, it fits it. F, this is also like a slope of, it's actually a negative slope. And then H is also a negative slope at about 2. So then that would immediately lead us to this. So I basically picked very specific points that help you go through it fast. I guarantee you're going to get 1 or 2 on multiple choice. They are extremely easy to do. You just have to pick like intelligent, smart spots. Okay, that's pretty much it for slope fields. If you look at your homework, the homework 1 through 6 on the front page, they're going to have you draw slope fields. And then you go to page 2, these are all the same slope fields. They want you to draw the particular solution on the slope field that you made, and then it also wants you to solve it by hand. And then there is a third page, but all of the work is on page 1 and 2. The two on the back page are multiple choice. So this could be a quick, I say could be because it just depends on how fast you are drawing. You'll find out these are very annoying to make. definitely why it's super nice to be able to have a computer and just graph them on the computer.
So many X's.